Welcome to the IT Fundamentals Training Series. Today, we're going to take a little bit of a dive into one of the complex subjects of virtualization. So join me as we take a look at what the book has to say about virtualization and how this can help us in the IT world be more green and more efficient. Welcome to the IT Fundamentals Training Series. This is your host, Mark Haupt, and today is episode 39, and we are going to talk about virtual operating systems. Now, virtual operating systems are all the rage right now, but if you did or will read your book, you'll find that the virtual operating systems have been around since 1967, so it's not something new, which is one of the things I hope you get from this training series, is that nothing we're really doing here is new. What you'll find is that it's terms that have been reiterated or concepts have been redone and rethought. And that's what we find a lot in the IT world, is it's almost, we talk about IT fundamentals. It's almost the same thing, perhaps with new names. But anyway, virtual operating systems, let's take a look at what those are. So back in my day, virtual operating system for someone who is just playing around or even perhaps working on computers or servers on their own, predominantly workstation type of virtualization meant that you would install multiple operating systems on your computer in separate sectors or containers on your computer, and the BIOS itself, by pressing whatever combination of keys, usually like an F10 or an F11 or F12 type of scenario, would allow you to choose the boot order that comes up on your screen. Now, of course, that still allows you to do that, but during that boot order, you could have selected, your Windows operating system or your Linux operating system. And as the book adequately defines or describes, that was a challenge, because you would have to literally stop one, reboot, or sign out of of that operating system, and essentially restart the computer, because the only way you get to that menu is to conduct those keys on the BIOS boot up. So that's how you did virtual operating systems, especially on workstations back in my day. If I was somebody testing, for example, I would need to build a computer that had those multiple operating systems on them, and then go through that process. And either that or the alternative would just be have a second computer off to my side. And then, honestly, that's what I did quite frequently, is to have my primary workstation that I'm working on, and then a secondary computer, which is usually, probably the computer that I most recently used. So I had my newest computer was the one that I was working on primarily. My older computer would be off to the side and allowing me to play around with those different boot sequences, if you will. And that's the way we did virtualization. But nowadays, you can do virtualization right in the same operating system, the same screen. And we'll get to those type 1 and type 2 operating systems in a moment. But let's just talk about the concept of virtualization. The idea here is that you can run multiple operating systems off of the same piece of hardware. That will allow you to efficiently use the computer and use the resources of their computer. And typically what we find on servers nowadays, for example, is that you may have, 5 or even sometimes 10 different server installs on a massive server, massive computer type of environment, or maybe 2 or 3 operating systems running on your workstation in virtualization mode. And what that will do is that will allow, through various means, allow all of them to operate simultaneously. And you can do various keys, like, it's not usually a Control-Alt-Delete, but it could be Control-Alt-Delete and then switching to a different machine, or perhaps remote desktop from one machine into another, things along those lines. But the really neat thing about that is if you have like an 8-core processor with 128 gig of RAM, and you have each of the operating systems that's designed to perhaps limit the number of cores or the number of processors, or maybe the number of gig that's being utilized on that system by that operating system, it will hit, potentially hit that max. But it could also share from one system to another. So if you've got 2 systems, for example, running side by side in parallel, and one of them set to use 2 cores, another one is set to use 4 cores. And let's say the 2 core maxes out, it could borrow a little bit from the 4 core scenario, or perhaps even from the reserves of the additional 2 cores that's not being used by anything and not allocated towards anything. Or perhaps if you've got 128 gig of RAM and you're running a database server and it's designed to use 32 gig of RAM for that, you got another server, it's an Apache web server, for example, that's running with 6 gig or I'm sorry, with 8 gig or even 16 gig of RAM. Then the rest of it's kind of sitting in reserve, and your database starts spiking. It could borrow some of the RAM from the unallocated space, and then it will be able to continue processing. So this is some of the good features, if you will, of virtualization. Now let's dive into what the book has to say about virtualization beyond that. So we're looking on page 204 and following. In fact, what we're going to do is really pick up with 205, because I already described to you a little bit. And first of all, anytime you have the italicized words, these are things you absolutely need to know for the test. So the very first word that's in there is virtualization that you're going to need to understand. Now, if you're still not convinced or still don't quite get virtualization, think of it this way, all right? In every single person's kitchen that we have in the United States or similar type of countries right now, you have a refrigerator, all right? Inside of that refrigerator box, you actually have 2 different functions. Typically, you have the refrigerator itself. We call the entire thing the refrigerator. You have a refrigerator itself, and perhaps underneath it, or maybe even back when I was growing up, the refrigerator is on the bottom and a freezer on the top. So you have 2 compartments. You have the freezer and the refrigerator. Essentially, what these are 2 separate compartments that are both doing the same thing. You are just setting the settings inside of the refrigerator to not be as cold as it is inside of the freezer. So in the freezer, you might set the temperature to be 25 degrees. And in the refrigerator, you might set it to be 38 degrees. And so that is the concept of virtualization. One box serving up 2 different functions because of the settings that you've applied. So when the term virtualization is used, think of it from that perspective. Think of it that you have the refrigerator and you're virtualizing refrigeration and you're virtualizing freezing. All right. The next word that it talks about in there that's italicized in there is one you might skip over if you're not careful. They've got the word computers in italicized there. And really what they're trying to do is they're trying to bring your attention to the fact that that's virtualization typically has computers in a plural sense. Multiple computers are involved in that. So that particular one is, just think of it that from that perspective. It's multiple operating systems. It's multiple functions. And again, we'll get to the type 1 and type 2 functions here in a moment. So the purpose of virtual machines is interesting, and I'm going to go right off the book here. The purpose of the virtual machine is to break down the one-to-one hardware and software barrier, and they described that function earlier in there. So what you're removing is you're removing a function where you have one installation of operating system for every piece of hardware, and now you're starting to use economies of scale, and you're starting to use the virtual machine to govern the various pieces of the system by having multiple operating systems on there, like we had talked about just a moment ago, where one is using one set of resources and then another. So we call those virtual machines. Now, going down to the bottom of the page, it talks about hypervisors there. All right. One of the things it doesn't mention inside of this book, but I do want you to get the understanding, is that there's a host and a guest. All right. Your virtual machine or your virtual machine manager is very typically your host. So if when we get here in the next page and we start talking about some of the functions of a type 1 and type 2 hypervisor, then you'll kind of understand this a little bit better. But you have a virtual host that then has multiple guest machines layered on top of that, and that's what you're looking at when you think about a hypervisor or virtual machine manager. All right, so let's take a look at those type 1 and type 2. So your type 1 hypervisor is something we also call bare metal. It's where you take the hypervisor software, such as a VMware ESX, or perhaps even Microsoft's Hyper-V type of product, and you install that just like you would an operating system right on top of the hardware directly. So you lay it right on top of the hardware, and then that acts as a manager for the interface between the multiple guest operating systems that you install on top of that hypervisor, and that's using the hardware resources that are underneath there. So a few moments ago, I talked about, hey, if you've got an 8-core machine and one virtual machine is using like 2 cores, another one's using 4 cores. So if you think of it from that perspective, looking at figure 4.13 there, you'll see that the hypervisor is laid right on top of the hardware. So the hardware is that 128 gig of RAM, that 8-core type of scenario. Right on top of that is the hypervisor that's managing what happens by the guest OS against the hardware. All right. And then, of course, you lay the application. You can lay multiple applications on top of that guest operating system. So that's a type 1 hypervisor, or what we call bare metal type of scenario. It's bare metal is because the hypervisor itself is being laid right on top of the bare metal or the hardware, and it's operating. That is the most frequently used type right now. Now, I want to say one thing about VMware ESX. If you want to play around with ESX, you can go and download a free copy of ESXi, and you can put that on your machine, and you can build up multiple guest OSs and start playing with it. That's a little bit of free tidbit, if you will, that's not part of the book. All right, type 2 hypervisor is where instead of putting the hypervisor directly onto the hardware, you put the hypervisor on top of an operating system, which is on top of the hardware. And then on top of all of that, you lay another guest, multiple guest operating systems. Okay. I personally don't recommend those types of scenarios, but these are very good for workstation type of environments where your base computer is running like the Windows operating system, and perhaps you want to utilize a hypervisor type of product that will allow you then to stand up inside of a shell a Linux operating system, or perhaps an Apple iOS, so that you can sit there and just on the side kind of play around with those operating systems. Now, typically the type 2 is going to be used by a developer of software code so that they can test their code against that operating system or that scenario that they want to test the code against. And very frequently, the type 2 hypervisor will be perhaps thrown away and destroyed after maybe a couple of days or a couple of weeks being operated. And so then it lays bare again, going right back to the host OS. So if we were to practically look at a type 2, you have your computer sitting on your desk that you're perhaps watching this video on right now. It has Windows 10 or Windows 11 installed on it. So that would be the host OS on top of your computer hardware. And then you decide to lay the hypervisor on top of that so that you can lay a guest OS of, let's say, Linux, or perhaps a second guest OS of maybe even a second copy of Linux, so that you can then lay the applications that you're testing against in Linux on top of that. And then at the end of that, when you're all done with that, then you probably throw away the entire hypervisor and leave your host OS back there so you can operate. Another function that this is useful for is like game development, or even perhaps doing gaming yourself. If you've got a game that is very efficient inside of Linux, for example, or different kind of shell, then you could perhaps bring that up inside of a hypervisor and operate. All right, so that's the difference between your type 1 and your type 2 hypervisor. Your cloud service providers are typically going to run type 1 hypervisors. The type 2 hypervisors are the ones that are going to be operating again for a developer, or perhaps something along the lines of you running some test machines at home or things along those lines. But the last thing that they talk about here is not really virtual machines, but it's embedded operating systems. And what they're talking about here with embedded operating systems are things that are running straight off of firmware. So some IoT type of devices, we've talked about those before. Things that like your Apple Watch might have that, or your different types of toys that your kids may use. They have a very small, very dedicated operating system that's embedded on a BIOS or on a chip of some sort that's inside the toy, and it just does very basic functions that's going on there. All right. Thanks for joining me in episode 39. And we will pick it up again tomorrow with episode 40. We're managing operating systems, and we're going to take a little bit of a deeper dive in that. So I appreciate you joining me, and I look forward to giving you some more information tomorrow as we manage the operating systems now. Adios.